Hi, this little video is going to look at oxidation and reduction. And in particular, we're going to look at a couple of terms that are used in this unit a lot. Reduction, the gain of electrons, and oxidation, the loss of electrons. And a couple of related terms that deal with the agents that cause these. To best understand these terms, let's take a look at an example. The separation of iron from iron oxide. The equation representing it is shown below. The idea is to take iron oxide and combine it with carbon, usually in the form of charcoal. That charcoal will scrub away the oxygen, leaving behind iron and producing carbon dioxide. Let's look at the oxidation states of all of the elements involved. I can see from this that iron's charge has been reduced. It's gone from +3 to 0, gained electrons. Simultaneously, the carbon has lost 4 electrons. For my definitions, I can therefore say that the iron has been reduced because it has gained electrons. The substance that caused this is called the reducing agent, in this case carbon. Simultaneously, I can look at the carbon, which has lost 4 electrons, and say that it's been oxidized. And again, the substance that caused this oxidation was the iron oxide. It's worth noting at this point that the oxidizing agent is itself reduced, and the reducing agent is itself oxidized. This might seem somewhat paradoxical. Now, we'll take a look at a couple other examples. First off, let's look at the combustion of methane. Again, I'll identify the oxidation states. From this example, I can see that the oxygen has been reduced because it has gained electrons to go from 0 to -2. The substance that has caused this would be the methane, and so it's identified as the reducing agent. Taking a look at the carbon, to go from -4 to +4, it must lose 8 electrons, so it's been oxidized. And the substance that caused it, the oxidizing agent in this case, is oxygen itself. I'd like to give you a little bit of practice with this. So let's take a look at the following 2 examples and go through the same analysis yourself. You might want to pause the video at this point so that you can look at the answers in a few moments. Welcome back. Well, check out the first one, see if you got those all right. The second one's a bit interesting in that none of the oxidation states have changed, so it's not a redox reaction. This is a pattern that will often happen. Double displacement reactions are not redox reactions.